Package management. So what I do, we have two kinds of projects generally in Go. As I said, I think initial number one binary, number two library or package, etc. So either it could be binary or it could be a package or a library. The only difference whether it's a binary or a pack library, you can also write the mix of both. That means both. What do you mean by both? You can have a library, sorry, binary. In order to execute the binary, you can also write your custom packages. That's what I mean to say when I say both. That's what I mean to say. So package management, when I say package management, we are creating packages. So you can create a pure packages. That means the whatever the package that we create, it got to be purely a package, or it is a binary where you generate a binary application, and then inside that particular binary you can also create a package. That's what the basic package management is. We have created some user-defined types. Let me go and then pick. Otherwise, we can. Okay, let's create our own. So the most important part of any package management, generally whenever you create a package and all, the most important part is the Go mod. So we have been using Go mod for every project, every application that we develop, but we didn't discuss much about it. Every project in Go should have a Go mod. Should have means, yeah, it is must. The old versions of Go, there was no Go mod actually. Go uses a different way of doing things. The old versions of Go does the different way of doing things. It's setting up the Go path, and then there was some certain things you have to do. There was no built-in package mechanism. I'm talking about Go version before Go version 1.11, very old version. Right now we are towards 1.24. I'm using 1.23, but 1.24 has been released as of today. Right. So I'm talking about Go mod. Without Go mod, prior to version 1.11, that was very old version. Comparatively, I think at least 7 8 years old. Fine. So the module name, whatever the module name that we give, this got to become the root path, virtual root path. The path is very important. Even if you remember about Go, in the initial days, we discussed about three things. One is called Go root, second thing is Go path, and third one is Go bin. Go root is where the Go is installed. Go path is where the third-party packages or the user-defined packages are kept there, or just segregated based on the domain name and then kept there. And the third one is called Go bin. All the binaries with respect to Go where we install with the go install command are going to be stored in GoBin. If GoBin is not set up, automatically GoPath is used as the GoPath bin is used as the GoBin. So these are the three important GoRoot, GoPath, and the third one is GoBin. Here GoBin is not set up. So what happens? It used the GoPaths uh, user jitin go slash bin that got to be used as the GoBin. Fine. We already are aware of this. Fine. So now we are going to create a package. The first thing is this module. Let me go and then create a module. Either I can go and then delete that file, go mod, and then create another file, go mod init, maybe shapes. It creates a new module with the name of shapes. Okay. Shapes is the name of the package. So we are going to create our own package and then going to use over here. That is what. So there are some few rules actually we have to pass with we have to use for the package with the package. Each and every new package in Go, it should have its own directory. That's very, very important. You cannot go and then create a package over here. You need to have a separate directory. You need to have a separate directory in order to create a package. Let's say that I say that, okay, I don't want to create a package, a new directory I would like to use here. You can use, but it cannot be a new package. You may have to use it as a main. If there at all there is a main package, if at all it's a binary application. What I'm trying to say is here it's a binary application. The reason it's going to be a binary because there is a main function, main package. The moment you see main package and main function, it got to be a binary. So in the binary, we are going to create a custom package. So as I said earlier, there should be a separate each and every package must have a directory. That is must rule. That is must. Then usually the name of the package and the name of the directory is same. That means, for example, I want to create a package called rect. I can go and create mkdir rect. I create this, creates a directory. Inside directory, I go and then create rect.go and then package rect. But the name of the file not necessarily to be same. Okay, the name of the file not necessarily to be the name of the directory or file name. The name of the file not necessarily. You can give even rectangle.go. That's fine. But the name of the directory must be the name of the package. Must be means it's again not must, but that is how it's kind of a tricky answer because even if you don't give, actually it uses alias. I will show you what do I mean by. But everywhere, most of the cases, 99% of the cases, people give the name of the directory and the name of the package are same because it takes the path. Okay, when it goes and takes the path, it takes the name of the actually directory. Fine, I'll explain that a little later. So inside package, what should be inside a package? Package contains all the variables, package level variables, which are global variables. Generally, we call them as package level variables. Also, we can call them as, and then types, functions, maybe interfaces. Type interface is also a type. You can create anything inside the package as long as the type is valid, the variable is valid with respect to Go. Then you can also create over there. You can create constants, you can create variables. Everything can be created over there. Let me create a simple rect. So I create a type rect, which is a struct. So I create a length and breadth, and then I create a and B. Go doesn't have access modifiers or access specifiers. Okay, you don't have public, private, internal kind of a thing in Go. You don't find public, private in Go. Initially, it looks pretty weird, but the moment you start using it, you feel it's pretty cool because you don't have any additional keywords. The grammar of the Go is pretty concise. That's the reason if people ask me, should I use a Pascal casing or camel casing in Go, the particularly the packages, uh, Pascal casing or camel casing depends on whether your type or a variable or a function, whatever you are going to use inside the package, it is exportable or unexportable. The concept is restricted field. There are two things people generally use, the restricted or unrestricted, exported or unexported. What do I mean by is anything means a package level variable or a type or a function, any symbol basically that starts with uppercase is exportable. If it starts with lowercase, it is unexported. We also call this restricted. That means, what does it mean? Uppercase is similar to public, analogous to public. Lowercase is similar to private, as simple as it is. But there is no concept of public private, but you have to, I'm just for your understanding, I'm telling public or private. We don't call it as public private. We can say exportable or unexportable, or we can say as restricted fields as well. Some say restricted fields. These words I picked from the documentation and all. This is not which I have created these words. Okay, fine. So now here, if you look at it, these two are unrestricted fields. These are restricted fields. I will explain it. What do I mean by it? Okay. Let's say I create a variable. Okay, and let me. Okay, fine. Let's say I'll explain. There is a rect and then there is a type called rect, and then I got to create a function over there, method over there. Let me create function new rect L and B float 32. We got to create a new rect, return address of rect. L is L and B is B. Now I got to create a function called area, float 32, return r dot a equal to r dot L into r dot B, return r dot a. You got to have perimeter 2 into we get the perimeter. Okay, let me say function r dot rect display. It got to just display the L is r dot length, B is this. Okay, so I have three methods, area and perimeter and then display. I've got a type called rect. Now let's go to main. I want to use rect. first of all. So if you want to use a package, the package is a library is called Rect. A package is Rect. It's a new package. But this project is not merely a package. This package is this particular project is nothing but it's a package and then binary. Fine. I would like to use Rect. If you want to use Rect, you have to import the package. How can you import the package? We import the package. We have to use this particular this module name is the root path. Generally, this name can also be given as a qualified domain name. github.com like that also you can give. I will explain that little later. Slash the name of the package called rect. So I can create R is maybe R1 equal to rect is name of the package dot comma new rect. I give some values. So R1 dot area and R1 dot perimeter, maybe A1 and P1. I got to print area of rect R1 A1 got to be A1. Okay, I got area of rect R A1 is A1 and then P1 is P1. This is what I got. So the most important part here is I cannot call R1 dot display. The reason I cannot call R1 dot display, display is a function method of R1 because display starts with lowercase. Cannot call display in another package due to it is unexported. It starts with a lowercase. Since it starts with lowercase, you cannot call it. If you want, you can create another function called display. You can call it as locally, since this can be called locally inside a package, since but not outside of the package. So I can call display capital letter. Cannot be called. It is restricted. But you can call R1 dot display because it starts with uppercase. And there are two fields R1 A and P. You cannot call them A and P as well. R1 dot A. You can't call them. Cannot be called. Cannot be accessed actually. It's not called. R1 dot P cannot be accessed because these are all unexported fields. You cannot access them. A and P. You cannot access A and P because they are unexported fields. That's what about the access. Everywhere, anything. Let's say I go and create another type. Let's say let me go and then create another type. Type T. For example, there is a type called T. The name is inside the type there is something called name. Okay. For example, there is a variable called private. There is a variable called public. If you look at this, I go here. I cannot create rector dot public only I can access because this is called unrestricted, but the type itself is restricted since it's a lowercase. When you look at these two package level global variables, private you cannot access, rect dot you cannot access private, but you can access public because it's unrestricted. It starts with uppercase, it starts with lowercase. So package dot public you can use, but package dot private you cannot call outside of the package. The reason is it is unrestricted. This is how you have to use even the functions, anything. Okay, just for your exam, this information, I'm saying this. Okay, let me go and execute this. You got the area and then you got the perimeter, whatever it is. It's a display function. The go to the display function. You got rectangle and then you get the details. Fine. So far so good. It is fine. Now, should the package be in the same file? Not necessarily. The package not necessarily to be in the same file. The package can be split into multiple files. Even the same part of the struct, if the methods to be attached, you can split it into multiple files. Okay, let me go and then create two files, maybe area.go and then may give as perimeter.go. But the most important thing is the name of the package. Package rect. The name of the package must be given. That's a very important thing. The main name of the package must be given. That is the most important thing. Let's say I go here, I take rectangle, uh, I take out this part, I put it over here, and then I take out this part, perimeter part, I can put it over here. You want, you can take. So you see that actually the package is, the type is created over here, but the methods are attached in a separate files. So there's no problem for Go. Go can understand because Go can glue all the things as long as they are from the same package. How do they know that? How does it know that all of them are from the same package? Because of the name of the package called rect. And one more thing in Go is the order of creation is not important. Order of creation is not important. Let's say go to rectangle. Okay, these two functions, two methods. I'm sorry, one is public and one is private. Let me take this. I can even call before the package. It doesn't matter. The order is not doesn't matter. Compiler is capable enough to understand and then keep the things in order. It's not like you have to go and then declare them. It's not like, okay, I'm going to use a display, so just go and then declare like this. You don't need to declare or anything. It's okay. The order is not important in Go, even in the main. Even in the main, the order is not important. Doesn't care about the order. Okay, it doesn't care about the order. The order is not important. That's the reason you can split them into multiple files as well. Go can understand. So when you run it, there is no change in executing them. That's fine. Now, what about the sub packaging? So I got a package. What about the, so this is the name of the module. Remember that this is name of the module. The name of the module is the root virtual path. The name of the module should be the root virtual path. Uh, Next example, I will explain about how you can give the GitHub location as the name of the module and etc. But this is the root virtual path. The name of the module is root virtual path. So that's how it got to be. So coming to this uh, thing, so I want to create an sub package. Let's say the best example of subpackage is math rand. So math is a package from the standard library in Go language, and rand is a sub library, sub package. Math rand. Whenever you want to generate the random numbers. Similarly, I want to create a sub package. So I go and create another directory. Shape is the directory. You want to create something called shape.go. Okay, you can create a package called shape. You can create a function called display. Shape package contain all shapes. Fine. Now I want to create something called shape, and I would like to move my rectangle to shape. The rectangle got moved to shape. Okay. So now what happened is the shape become the root package. Still the rectangle, everything, there is no change in the rectangle. But when you call the shape, when you call the rectangle, you have to call with the directory structure. So you have to put shapes. Inside shapes, which is the module name, there is something called shape, which is a package name, and inside that there is something called rectangle, rect. So you got to call it as a rect. So this is a sub package. Let me go and then create another package. Let me put it as a square. It's a sub another package inside the shape. I can go and put as square.go. The name of the package is always the name of its immediate directory name. The name of the package is the name of the its root directory. Its root directory means this file's root directory. What is the root directory of this file? It's a square. What is the root directory of the square? Is shape. What is the root directory of shape? Which is this project, but virtual name we use it, which is the name of the module. So type square is float 32. Function square of area return s into s, which is square, but we got to convert it as float 32 because the result is float 32, and then we got to have something called the perimeter 4 into s. Now square is also inside the shape. You want to create square. I go here, I create square. S1 is square dot square of some number, and as usual you can call s1 dot area and then s1 dot perimeter, and of course you can print them usually. Area of square a2, area of square, perimeter of square is p2. So automatically this comes here. If it doesn't come, you have to go and manually write it, the name of the package and stuff like that. This is a sub package. This is a sub package. Let me go and then put it as a inside this. I create something called like how we used to do. Type in interface, I shape. I create an interface. I write area. I write definition called area. I read definition called perimeter. I read definition called float. What? So what has to be implemented for both? Function yes, square is what? It let it be a string so that I can understand what it is. Return square. Return rectangle. Okay. So again, I have something called shape, I shape, and then here I simply write function shape. You call I shape is I shape. You got to print fmt.println area of type. So I shape dot what is I shape dot area. Similarly, perimeter of type perimeter. So I have I shape. So where is I shape? I shape is from the package. So what I can do, shape dot shape of, if you want R1, you can also call S1. Temporarily I'm parking it aside these two. I don't need to call them because I'm using through iShape. I hope you understand all the things, how I created. I call this because shape is a function which is from the package called shape. Now, that's fine. So we create a package, we create a root package, we create a sub package, we split it into multiple functions of that particular sub package, multiple files inside the package, sub package called rectangle. Okay, there is something you might have seen in many areas. What if what if the name of the package I give it as rectangle rather than rect? Okay, yeah, rectangle rather than rect. Instead of rect, I give it as rectangle. You can give, there is nothing wrong, but the problem is Go cannot understand. It feels that there is some contradiction between the name of the directory and the name of the package. Usually the name of the directory must be the name of the package. Not must be, but that is how. If at all you give a different name of the package is different than the name of the directory structure, then you have to use the alias and you need to call with this particular alias. Okay, you need to call with the particular alias. This is where the difference comes. So still it uses the same path. So always try to give as much as possible the name of the directory and the name of the package inside the file. Make sure that they are same. As I said earlier, 100% we cannot make them as same, but try to do it as same. Okay. Uh, Particularly when you are writing testing packages or using any third-party tools like GoMock and all, or gRPC based tool generators and all, they give a different package name. generally to understand that it's a gRPC package and all. They don't give the exact same. Usually, we don't ask the tool to give the same package name, but we use maybe gRPC or proto or a mock, something like that we give to understand that, okay, this is a package that got generated, not by created by us. Because generators, there are so many tools which are generators that generates the packages as well. Like gRPC, there is a tool that generates the package, something like that. So we don't give. Sometimes we give, but normal packages and all always give the same name. We can give, but this is what you have to use. Okay, fine. The other thing is, you see that there is a package called time. Let me say there is a package called rand. Okay, what I do is math slash rand. I want to generate random numbers, for example. Okay, for example, I equal to 1, I less than or equal to 10, I plus plus. Now you can use the range loop for that as well. For I 1 range of 10, you can do this. You we can do this. I think how I forgot the syntax again. The range loop on numbers, how to generate. So I think for if you want to use a range loop on numbers, okay, let it be. I think this is how it is supposed to be. Sorry, I forgot the syntax. Let's say I create a loop, normal loop. Let me create. We can range loop I less than or equal to 10, I plus plus. Okay, I want to use the random numbers. If I want to use the random numbers, I can use rand dot int n, for example. Okay, and then I want to print whether the uh, random number is even or not. If modulus 2 equal to 0, even number can say n. Okay, n modulus 2 equal to 0, even number. N is even number. For example, this is what you got to do. So if you see that the rand dot intent, you have to use the package called rand dot. There is a way in Go language. I'm sorry, you have to always just have to stick from math. There is something in Go language. What it does is it generate random numbers. It generate random numbers. Math dot rand. For example, I don't want to call the package name. I don't want to call the package name. Okay. Uh, I don't want to call the package name. I just want to call the function. You can put a dot. The moment you put dot, okay, whatever the function you got to use, you can directly use this. The moment you put dot, many times you see that where is the package name? How can you call? This is not a built-in function. The reason it's not a built-in function, you can call it because you put a dot. Let's say I put dot time. There is a problem if the names contradict. Okay, so I can call it as now. Now maybe dot Unix time. So what is this now? Now is a function. How can you call now? Because with the dot, you don't need to call time dot now. You don't need to call math of star. This is very rarely used, but you can use it in Go language. Okay, this is very rarely used, but you can use it in Go language. Directly you call the function. It's not a built-in function. This is not a built-in function. Whenever you see something like this, either the function got created over here or the function got called like this. Okay, the function might be called like this. You need to know that. So 8 is even number, 72 is even number, 68 is even number, might be my other. So this is the Unix time. This is the Unix time. You could see that, but we are just calling now.unix. Now is the function now.unix. How you can directly call the function because you are using the dot operator. You just use dot, so you can directly call them. Okay, this is what I'm actually basically about packages right now. Let me push it. One thing about that package management is the package that whatever we have created over here, it is not purely a package. It's not purely a package. It's both actually. It's not purely a package. It's a mix of package and as well as the main function. Mm, it's a mix of both. What I want to say, it's a mix of both package and a main. Both are there. What do I mean to? What do I mean by is there is a main function where we are calling the package. The package is created inside the same module. Now let's create a separate package instead of creating a package and the main function. Let's create a separate package. What I do is I copy this application 61 to maybe 62 package. Let me put it as shapes is the package. 61 to 62, which has got shapes. This shape is the package. So how do you differentiate the package and then with the main? If you delete main, this becomes a pure package. That means it's just a package. There is no main, so this is a pure package. And then now it's a pure package. The most important part is, if at all you are working on packages, if it is a pure package, the most important thing is go mod. Actually, I give it as shapes, but what is going to be the mod file? Generally, mod is given in most of the projects. Mod is given the GitHub link. Even for the Java, there is an artifact ID and then group ID, something like that. We give a qualified URL, qualified and unique URL. Similarly, even generally Go, what happened? We give the proper module name. We give the module name as the GitHub. So what I do is I create a pack URL. Let me go to the github.com and then generate a URL, create a URL. This got to be the URL I give. I just gave it as shapes1 because in my GitHub repository already there is something called shapes. It's okay. I gave it as this is the URL. Qualified path. Generally, uh, this is how it is created. Okay, this is a qualified path. Why I said qualified path? Because this URL would not be duplicated, because I cannot go and then create another shapes1 in my repository, in my GitHub account. You know that this is unique. And then what I do, I have to push it to the GitHub. So I just init as a git. It is created as another GitHub repository, and then I'm copying the from the GitHub. It got added as a GitHub repository. You see that git remote add origin. This is the GitHub repository, and then git push. It got pushed. So git add, git commit, git shape repository, git push. This adds the repository, git status. Yeah, the branch is up to date with origin main. That means it got pushed completely. Now I have the repository. So where is the repository? The repository is in GitHub. The most important part is the name of the module. I told you even earlier, name of the module is very imperative while creating packages. We have been giving as a demo just for the purpose of the demo, but actually this name is very important. This name is very important. Okay, now what I do is I create a consumer. Okay, this is the package that we are using. Let me create it as a consumer. So I go here, I copy I copy stub as 62 shapes consumer. That means we got to consume the package. Okay, so this is in the GitHub. Assume that this is in the, not assume, just think that it is in the GitHub. It's not in my machine, for example. It is in the GitHub. I'm directly consuming it. So first thing what you need to do is, before going to consume any package, you need to pull the package by using a command called git pull. Okay, you need to pull the package. Whenever you are consuming the package, you need to pull the package. That means pulling the package from GitHub or Bitbucket or any remote repository to local. Actually, for that what you do, you use a command called go get. So what do you go get? You take the repository. Generally most of the packages, they give proper documentation. Go get the repository. This is the repository name. So what it does is it goes to the GitHub. Okay, it tries to pull the repository which is available, the latest version, of course. Go get command is going to get pull the repository. Now, it if you look at the repository, where is it? Shapes repository. This is the name of the module. Remember that this is the name of the module. The whole thing is name of the module. Okay, fine. I go to my git.mod file. You see that require, this is the tag. Generally what happened, you create versions, we tag it as versions, and then we push the repositories as versions. That's how generally we do. Okay, we tag it as versions and then we push the repositories as versions. Okay, that's what we do. But here we have not created any version as such, but we have pulled we have pushed the latest, we pulled the latest repository here. Because we have not created any versions, you can create a repository, add it, tag it as a version, and then we release it. There is some process for that, right? In GitHub, in Git process, there is a process for that. Okay, that's what, there is a process for that. Fine. We just pulled it by using GitHub. Go get is the command. Okay, you want to get it, go get is the command. Go get anything that you would like to pull. You get the, generally you get the documentation. Let's see, to get a repository, to get a package, you have to use go get command. There is another way. Okay, first let me do this. After that I'll explain. Now I want to work with rectangle. Import, you know that it's called github.com. Shapes 1. If you save it, it gets deleted, so the best thing is put a blank identifier over here for the moment. But shapes 1 is not a package. Shapes 1 is the module name. You are inside that, you are using rectangle. You need to know the hierarchy. There is something called shapes. There is something called shape, and there is inside there is rectangle. Here you use it as rectangle. This rectangle, we create an object, rectangle dot, I don't know, it has to, no required module provides package. Let me put it as square. So let me put it as square. I will see that new square of, I think we have not created any square like this, square of some value. I think there is, okay, there is some the problem with the uppercase, lowercase. Because I gave it as uppercase here, that's the reason I got square. Similarly, I get it as a rectangle. We have to use it as R1 equal to rectangle dot new rectangle dot some values. Okay, this is where it pulls from. That's why I gave here. If you give this, because I gave it like this, the reason is the name of the package is not the name of the directory, so we have to give like this. I cannot give R1. I can give as well, yeah, because it's alias, but that's not a correct approach. The reason is the name of the package, the path that you, I'm sorry for that, the path you always give as the directory path. This is the directory path. This is the root path, which is called the module name, and then here onwards it would be the directory path R1 also. Sorry, I cannot give R1 because the same name I give. So I give rectangle. This is just alias name dot new rect. You got R1 and you got S1. This is the path, the directory path. I give the alias over here. Fine. Now you know that R1 dot area, simple thing. You get area, and then of course perimeter. Let me use the shape. There is also something called shape. So I create a variable called iShape is shape dot iShape. Automatically shape is pulled here. So this got to be the shape. This got to be the shape, iShape, and then I call the function called shape dot shape. Shape dot shape. Here I can call R1. Again, I can call S1. This is going to print the shape. Okay. I'm going to explain something else. As you know, you want to call them everything in local, or as if it is called, just you can put a dot. Those things work. So these things are same. It understands that you are calling it in the local everything, so it comes like that. You can give shape. Sorry. So what happened is, what is the difference between the earlier one, this one is, there is no package over here. We are just using the package from internet. That is the most important thing. It's a third party package. As I said earlier, there are three kinds of projects. There are three kinds of packages. The three kinds of packages are package you can create within the main, and the packages are standard packages. Standard packages are the packages that are shipped along with your Golang, which we call them as standard packages. And the second thing is packages that you create. That's what we have done earlier, maybe with main or without main. With main or without main means, in the sense here it is within the main, with main also there. Here it's not without the main, but it's a package you create, probably with main. And the third one is called packages that are third party packages. This is considered as a third party package, even though I only create and I pushed it to the internet. and then I am consuming from the internet, it can be considered as a third party package. Assume that somebody else has pulled the package, not you. But here, for example, I created the package, I pushed the package, and I am consuming the package. Generally, we can consider it as a third party package over here. We are running this, and let's go and run. You get the details. And the same package management fields like restricted, unrestricted, everything is same. Everything else is same. Now, a simple scenario we can discuss over here. For example, shapes package is not created by you. Shapes package is created by somebody else, maybe inside your team. First of all, I'll explain that. Shapes package is created by somebody, some other team. Okay. Shapes package is created by some other team, not by you. Then you pull the you started using the package. You pull the package. The package is come to your machine like this. You pull the package. Now you found a bug with the package. For example, you found a bug with the package. Okay, there is a bug in the package, or you got to add a new feature to the package. Let's say I go to shape. Maybe I add a new function called, okay, what is the function inside that? fmt.println shapes package. It works with all geometric shapes. For example, what is a function? It gives a message. It prints something like it works with all geometric shapes. That means I pull the package. I pull the code. I clone the package. I mean to say, I made changes in this particular package by adding a new function or fixing a bug, whatever it is. Then I got to use this particular function. I want to use this particular function. But you are not the owner of this package. You are not the owner of the package. You are not the owner of the package. You got the code with you. So you are not supposed to push the package. Number one, unless it is tested well, you cannot push the package. I made changes in my local code. Okay, it is as simple as it is. What I am trying to say is, okay, I delete this code. For example, I go and delete the code. So there is no code. Okay, I am consuming it. Still I can consume it because the code is not required. The package got downloaded internally into the Go mod cache. Fine, the package got downloaded and stuff like that. Now I feel like there is some bug in my package. So this particular package, I go back here. I say git clone of this package. So I got this package into my local machine. I go and made changes. Let's say simple function called I just write a function called what is going to print out something. Now how can I use it here? Because it is I'm not using this exactly, this copy. I'm using the copy from the internet, but this got changed in your local system, and then you may not be able to push it unless it is tested, and you are not the owner as well. There are two things. You are not the owner, so you cannot go and push to different repositories when you are not the owner. You are not supposed to push unless someone gives you the access to push. And the second thing is, you want to test it before going to push. So the here then we use a concept called replace. So I go to my Go mod. This is my package. So just write a stanza called replace. What you got to replace? I got to replace this one with the local directory. That means a relative directory is fine. You're telling that okay, this is my package, I got to pull it from internet, but this one you replace it, this one you replace this one, you put this with the local package like this. That means for the development purpose you can call the function. You know what is a function from shapes. Why I didn't call the shape name? Because I gave dot over here, just for you to understand. So I go to 62. Okay, shapes is used to get area and perimeter for all geometric shapes is what actually I wrote. Now you test it, you feel like it is working very well, you don't have any problem, you are pretty much comfortable with the way how things are working. Now you can push it. If you can push this one if the repository owners agreed, or you get access to push. If you can't, then you may push it to your local repository or something and change the stuff. If you push it to your project related repository, you have to change the module name, and then because this is very important, you have to push to the same repository. You cannot give some name here and push to different repository. There is a contradiction. You cannot do that. The name of this repository is where you have to push. Okay, you have to push to the same name of the repository. Fine. You understand. So what I did, once again, I pulled somebody. I started using third-party package, and then I found that there is some bug in the third-party package. It's a public package if it is open source or something. If it's a private package, that means it belongs to your own organization but a different team, your own project but different team, different business unit. Maybe like loggers, common packages, and all email services people write. So you can pull the package, you can clone the package, probably you can make changes, you can fix bugs, and to test whether it's working fine or not, you can go here and then you can use a stanza called replace. So temporarily you cannot use replace in the production environment. This is only for the development, to ensure that the changes that you made in your local system, they are replicated, they are working very well. Once you are confident that this is working very fine, when you could push it, you need to push it and then change the version information, because once you push it, it would be the latest tag, not this hash. Okay, and then you can remove the stanza. So when do you push? If you get access, otherwise you can't push it. Okay, that is something. Okay, I hope you understand what I'm trying to say. Now there is another problem. Generally, if you go to 62, CD 62, we are consuming the package. Fine. There are two things that we generally come across with Go. There is something called Go mod tidy, and then Go mod download. Here I do it go get. Here I do it go get. Actually, you can use Go mod tidy as well. You can also use Go mod tidy. Let's say I give here rand dot int n of 100. No, that is it. I got math.rand. Okay, not the math.run. I'm trying to use the third party package. Let me check for any UUID package from the third party package. Let me check one second. Okay, Google has given that UUID package. There is a package called UUID. It's a Google UUID package. Okay, let me UUID. It got a UUID. Now the moment you save it is gone, because unless you use it you get some error. So I can put a blank identifier. I can do two things here. Number one is you can go and then do go get. Of course you can do go get. The second thing is go mod tidy. There is something called go mod tidy. So what go mod tidy does is go mod tidy goes it goes and then downloads the required packages. So go mod tidy also ensure that the version information, okay, there are two files. One is called go mod and then go.mod and go.sum. So it ensure that go mod tidy. The reason I'm talking about go mod tidy, there are two things. One is called go mod download and then go mod tidy. Go mod tidy particularly ensure that actually the version information and both in go mod sum and go mod are same, because this is what the version that I'm using, go mod sum. It ensure that the proper version is maintained. So what I do is I call go mod tidy. Go mod tidy tries to pull the package from internet. It has pulled the package, the latest package, actually the latest package version 1.6 from the internet. You go to go mod, you could see that this is the package it has pulled. Okay, you go to sum, make sure that proper hash, proper commit log is maintained. Fine. Okay, now I use this package, got a UUID package. Okay, I pulled the package but I'm not using the package. Okay, probably you have to use the package. You have to go to the UUID and then I'm in the documentation. Basically you go to UUID, you can go to I'm just checking is there any example. You get a UUID, particularly UUID package is pretty important and useful package. And you can create a UUID UUID.new. You get a new UUID. You can print the UUID. I'm not doing anything right now, but just getting and then printing the UUID. You get some UUID. Okay. You can also create node level UUID. There are certain things that you can do with the UUID packages. You can use in cloud-based applications as well. But just now, I'm showing you how you can do this. Now. There is a problem over here. UUID is managed and maintained by Google. There is no problem. What if you pulled a package, it is used by third party, and then tomorrow that guy or girl or whoever, that company, as it could be a company, they go and delete the package from the repository. What if they delete the repository itself? What if they delete the repository as well? So three things here, two things here I explained. One is called go get, and the other one is go mod tidy. Okay, tidy, it cross checks everything in your Go project. Okay, it cross checks everything. Go get, it go and then pull, get only that particular thing. Okay. So yeah, we used to go mod ID, right? That's what I'm telling. Now what I said is, what if Google doesn't delete generally? What if any third party package that gets deleted, but you started depending on the package, but what if it gets deleted? There's a problem like that. So what some folks do is, if at all they are using packages from unauthorized repositories, that means the repositories that are not managed by big companies, they can vendor it. So there is something called go mod vendor. What it does, it creates the directory called vendor and it pulls all the code from vendor directory. See that github.com, within the GitHub it maintains the code. Here is the code. Both two packages are used over here. The two packages code is used here, but what happened, it bloat your repository, because you're not only pushing your repository, you're pushing somebody else repository as well as a vendor directory. The size of your repository may be bigger than expected, but generally this is a safe approach, particularly when you are using packages, third party packages that are from unauthorized repositories, unauthorized users. It's a good approach. For example, I create this package, you are using a package. Tomorrow what if I go and delete the package? Because you always pull the package from the internet. So some organizations, many organizations, they follow vendor way of doing things, because vendoring is very good, actually very safe. Even the code is not available in the repository, the repository gets deleted, still you have the code available within your repository as well, in a directory called vendor directory. Vendoring a package means it creates a directory. Okay, that is what go mod vendor. And there is something called go mod download. Okay, there is so for three commands we see. Number one, go mod tidy. You understand what go mod tidy does. Number two, go mod vendor. You understand what go mod vendor does. It vendors. It creates a directory called vendor and it pulls all the code from the vendor directory. And the third one is called go mod download. Actually, there is always a discussion between go mod vendor and go mod tidy and then go mod download. Particularly go mod download, you just need to fetch the dependencies, particularly when you are working in CI/CD or when you are working offline, you can use go mod download. But go mod tidy is much more bigger than this. Go mod tidy does much more things than go mod download. So go mod download only downloads the dependencies. The dependencies means packages. All the modules that are supposed to be downloaded, they gets downloaded to the cache. There is a cache directory. Generally that cache directory is nothing but go path. It downloads to the cache. What go mod tidy does, go mod tidy ensure that the go.mod file and go.sum file are correct. Why it is correct? There could be, let us say that I make some change to a version, but unknowingly I push the same version, or somebody else from your says from your company, from the same project, they might have pushed it to the same version, so there is a change, the version number is changed. Generally it is not supposed to happen, it's a bad practice, but the version number is same, but there are two codes, two different implementations are there. Generally it doesn't happen, but still there are chances. If CI/CD pipeline in the are not properly set up, there could be a chance like that. Even I have seen that folks, they unknowingly pushed tag a version, let's say v1.4 for example, or v1.3, and later they realized that there are some bugs, and then they delete the version and then they push the same version. Usually it is a very very bad practice, but I could see that, I could see initial days many people did it, but later on a lot of DevOps strict practices come and all. Actually version is automatically given, it's not you manually give the version. Okay, since the version is automatically given, then you cannot tamper with the same version. Okay, so go mod id ensure that the versions and the tags which are mentioned in go.mod file and go.sum file, they match, they're correct. And go mod id may change or modify your mod file or sum file based on what exactly you are doing. We ourselves went and changed the mod file by replacing it. Okay. It also removes the unused packages, missing modules, missing packages, etc. Go mod id. Go mod id also removes the unused packages, unused modules actually. So go mod id requires internet because it fetches from the internet, whereas go mod download is little different. Go mod download, it it downloads the module to the cache. Of course even go mod id downloads to the cache, but it does more than that. But go mod download is not going to remove unused packages. Okay, go mod is not going to change your go mod download is not going to change your go.mod file or go.sum file. Okay, there is an offline support with go mod download because particularly in CI/CD pipeline we use go mod download. The reason is it can check for the packages that are whether they are locally available or not, and then it goes and then use from the cache if they are already available in the cache. So there are two things, go mod tidy and then go mod download. Tidy is more intelligent because it checks your go.mod file and go.sum file. Okay, download, it doesn't do all these things, but it downloads blindly to a cache. Okay, what to use? I prefer to use go mod id more frequently. Because I always use go mod id because it checks the versions and stuff like that. But if at all writing my Docker file and all, I just put go mod download because only once it pulls and then it start working, because I'm not going to change inside the Docker anywhere. I'm not going to change my code inside the Docker, so I don't need go mod id over there. The third one is go mod vendor. You understand what is go mod vendor? It vendors the directory. That means all the dependencies comes to your repository in a folder called vendor directory. And we also saw that how do you change the code inside your local system, and then how do you replace the GitHub repository with your local repository temporarily, not permanently, temporarily. Because the process is, after you make changes, you feel like it's good, there are no bugs, you push it and you tag it. So before going to push, you would like to use anything, then you can use uh, this replace stanza. Okay, that's what about that's what about the package management in Go.